All right, so we're on to the next method here, which is called superposition. I personally really like superposition. I think students in general really like superposition. It's pretty straightforward. Really makes solving circuits pretty easy. But there is a little bit of a catch to it, which we haven't talked about yet, and that is the first step, which is removing sources from the circuit. Okay, so I'm not going into the general process. You can see that that's in the next slide. But the first step here is remove all but one source from the circuit. And so we may not even know what that means, what that looks like. In fact, we probably don't. So I'm going to talk about it in this slide before I get into the general process. And so if I'm using superposition to solve a circuit, generally requires that circuit has more than one source, okay? Because the whole point of superposition is to basically solve the entire circuit as if all of the sources are missing except one, and then we go through that process until we've solved the circuit for each individual source, and then we sum up all the results, okay? But for now, I just want to talk about what it means to remove a source. So let's say I have a circuit. It's got a voltage source there. Maybe I put, a current source here flowing this way, and I'll put a resistor here, okay? And then I'll just ground the bottom node. Okay, and then I'll actually go ahead and just make a little copy of this circuit, and I'll put it on the other side as well so that we can use it for the removing a current source part 2. Okay, so when I have a voltage in my circuit, a voltage source in my circuit like I do here, what that voltage source tells me is it tells me the voltage between the two nodes that it's connected to. So again, if this was a 5-volt source, I know that this top node has to be 5 volts higher than this bottom node, right? Okay, so if I want to remove a source from the circuit, a voltage source specifically, what I need to do is I need to simulate 0 volts between those two nodes. I want to effectively, as if there were a 0-volt voltage source there, I want to remove the source completely, and I want that branch of the circuit to act as if there was a 0-volt source there, or a short, okay? So let me go ahead and, if I were to remove a voltage source from the circuit, I would just put a short in its place. And that guarantees that I have the same voltage here as I have here now. In this circuit, right, I just removed the voltage source. And so now the ground node is basically extended all the way up here because I have no element there. So that would all be 0 volts now. So I've effectively removed that voltage source from the circuit, okay? But removing a current source is different, okay? With the voltage source, I wanted to basically simulate a 0-volt voltage source so I can replace it with a short. With a current source, I want to replace it with a 0 current source, right? So a source that has 0 current would be a branch where no current could flow. So I would replace that part of my circuit with an open, okay? So now this has I equals 0 because no current can flow into that open circuit. There's no elements here to conduct current, okay? And so that this branch now, this entire branch, let me go ahead and get my highlighter again. This entire branch would have no current flowing in it at all because there is no path for current to flow. So the effective circuit would just be this piece here because I would have no current flowing here. Okay, so really the takeaway from this little video or this slide is that when we get rid of a voltage source, we replace the voltage source with a short circuit or a wire. When we get rid of a current source, we replace it with an open circuit, right? Because we want 0 voltage here and we want 0 current here. All right, so with that in mind, I'm going to go ahead and stop this video. This is just a little introductory video about removing sources, and then in the next video, I'm going to go into the process for using superposition to solve a circuit.